Detention.
Shut up.
As the air is moving, across into open water, it gets cool and moist. Why? It's over water now. This air mass that's moving is going to get wet. Okay, so now it's a maritime polar air mass. Now we've been talking about air masses. Now we're going to talk about lake effect snow. Now lake effect snow is kind of cool. Now you have this continental polar, so this dry and cold air coming down from Canada. It hits the water. And it hits the water and it gets a lot of water. It soaks up this water, and then that air then goes over the land. Well, the land is colder than the water is. The colder air can't support all of this really wet air, and all of that wetness comes right out and dumps onto the land. Anyone here have family from Rochester or Buffalo or Erie, PA? In Buffalo? How much snow did they get this winter? You don't know? I had another student who has family in Erie, Pennsylvania. They had something like 15 feet of snow. 15 feet of snow. So they don't measure snow in inches. They measure snow in feet. So I have a picture of it. Look at this. Here is Lake Superior. This is Lake Michigan.
Oh, that's a satellite?
Satellite image. This is actually Michigan itself here. Now what's happening is this cold air is rushing over the lakes and it's evaporating water off the lakes. The water is going into the sky, hitting clouds, and as soon as the clouds gets over the land, doosh, there goes all the snow, and it moves on, and Buffalo, once again, is under snow. Get this. It snows so much there so quickly that you could have a snowstorm and then not be able to open your door in the morning because there's that much snow.
So how do they have school there?
They know how to deal with snow. Unlike us, where you have an inch of snow. Ah! Snow!
No school for 2 days.
Yeah, exactly. So let's talk about fronts. We've been talking about air masses. We're going to transition. We're going to talk about fronts. When two air masses meet, they get in a fight.
What?
When two air masses meet, they typically get in a fight. And this fight is known as a front. If two armies array against each other and they fight each other, the line where the army is fighting is called the front line. The front line is the point where the two armies are meeting. So the same thing in the air. When the two air masses are getting into a tussle, they're fighting each other, we call that a front. There's 4 different types of fronts that I'm going to talk about. You can have stationary fronts, warm fronts, cold fronts, and occluded fronts. But before we talk about that, you need to understand that the fronts are typically where the rain and what we understand as rainy weather come from. They typically come at the front. Now, you have different kind of clouds, different kind of weather. Not every front has the same kind of weather. Warm fronts have rain that lasts over a couple days. It's typically kind of dreary, drizzly, overcast, rainy, nasty days. Warm fronts. Cold fronts, you get big thunderstorms that come, boom, go, gone. And they're just whoosh, go through. They're very quick moving. Occluded fronts, it rains really hard for a really long time until the whole thing fizzles itself out. And a stationary front is what we're going to start with. A stationary front is when two air masses slide past each other, neither trying to take over. So this is the only time that there's a peace treaty between the two fronts, between the two armies, between the two air masses. You guys, if you go to a softball game or any of these sports games where they make the teams line up and pass each other, good game, good game, good game, yeah, whooped you, good game, good game, oh, they beat us, good game, right? You know what I'm talking about?
Yeah.
That is a stationary front. You have two air masses going past each other, doing that. All right, good game. We're not fighting right now. We're not competing. We're at peace. Nothing's going on. Now, as that air mass starts to develop, that system is called a low pressure system. As it starts to get lower and lower, low pressure systems tend to turn in what direction?
Counterclockwise.
Counterclockwise. And when they start to turn counterclockwise, the warm side starts to push the cold side out of the way, the cold side starts to push the warm side out of the way. And you get fronts. I have pictures of that. But first off, let's look at a warm front.
What?
Warm front. There are some things you need to know about the warm front. You need to know that the symbol for a warm front on a map is a red line with semicircles. Okay? A red line with semicircles. Now, this warm air is kind of light and fluffy. Why? It's warm. And warm air is less dense. And when it's less dense, it has a much harder time getting this cold air out of the way. Actually, I should do it on this side. It's trying to get the cold air. Go away, cold air, you big jerk. I'm here. I'm going to be in charge. But it does a really poor job of doing it. And so it tends to, the warm air gets shoved up and over the cold air as it pushes it out of the way. Well, we know that if warm air rises in the sky,
Cold air denses.
Denses? What's it?
warm air rises in the sky. As air rises and is forced higher, all of that air gets colder and colder and colder as it gets higher in the sky, because the higher we go, the colder it gets. And it can't hold the moisture anymore. It's warm, wet air, but it can't hold the moisture. It turns into a cloud when it saturates. We learned this a couple classes ago. So we get nimbostratus clouds. Wait, nimbostratus, that means the cloud is nimbo. What does nimbus mean? It means that the cloud is
Fluffy.
Light.
Precipitation.
so the cloud is
Light.
raining.
I said that.
You said it so quietly that nobody heard it but you.
Well, I'm all the way in the back. Nobody can hear me unless I get this loud.
Is that you did that?
Hello.
What are you saying?
Okay. If it's a nimbostratus cloud, it's a wet, rainy cloud. All of that water is getting wrung out of the atmosphere as there's less and less room. Now the clouds continue to rise, but now up here they're not raining. And they get thinner, and as the air gets above the cold air, it gets higher and higher and higher, thinner and thinner and thinner, until eventually, at the very front of the storm, or the front system, you just have these wispy cirrus clouds. So this Sunday was beautiful, right? This is really,
yeah.
really pretty on Sunday. What was I doing? I was sitting on my horse. And
Wow.
I'm sitting there on my horse,
Yeah.
and
No.
I was actually sitting on my horse. We weren't walking, we were just sitting there, and there was talking to some people at the barn, and they said, I think it's supposed to rain. When is it supposed to rain? I don't know. I said, well, let's look at the sky. And I seriously did this. This is how much of a dork I am. Okay, I looked at the sky, and I said, aha! Clouds! What does that tell us?
Nothing.
Well, it did tell me something, because what did I see in the sky? I saw cirrus clouds. And then I looked into the distance. And as I scanned into the distance, I saw clouds getting descending in the distance. Wait a second. Ding, 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 ding. Cirrus clouds followed by cirrostratus clouds in the distance. I said it'll probably rain in the next day or two. Why? Because I know that this system slowly trucks its way forward, and the clouds get lower and lower and lower. And sure enough, by Monday morning on my way to school, it had started to lightly rain. And throughout all of Monday, what was it? It was just rainy, wet weather. And then Tuesday, it was still kind of rainy, nasty weather. And then it's slow, and today it's nicer. It's not nearly so rainy anymore. Because the whole front took about a day and a half to move through. Took about a day and a half to move through. So you get a whole lot of light rain over the course of time. Light rain, long time. Warm front. Okay? Does that make sense?
Yes.
Awesome. Then we'll go to cold front.
Oh no.
Now, cold fronts, I think, are much more exciting. They're much more dangerous, that's for sure. But they're much more exciting. Now, a cold front, symbols, you have the blue line and the triangles. Okay? Blue line and triangles. So on a weather map, you see blue line and triangles. Well, you got to think. Warm front, red, warm. Cold front, blue, cold, right? So, while the warm front is kind of light and fluffy, cold front does not have that problem. Stay awake. Cold front is thick and dense It's kind of like a bodybuilder who's so thick and heavy that when they get into the pool, they sink to the bottom. Right? They can get under everything. Well, this cold air goes and hits the warm air, and instead of getting spread out on top, it shoves all the warm air up in the air, and the cold air scoots under it. Well, because it does this quickly and very, very short space of distance and time, all of this warm air goes straight up. Instead of being spread out, it goes straight up. So it's all those clouds that are spread out, all that same moisture is now up and down. And that creates a big cloud. A cumulonimbus cloud. Oh, nimbus! Nimbus, what does nimbus mean?
Wet and rainy.
Wet and rainy. Okay. When you get a cold front, cold air meets warm air, you get thunderstorms. Especially in the summer. These are known for their thunderstorms. Because all this cold air is pushing this warm air just up, 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 up. And the clouds go all the way, almost as high as you can see, and they go to the very top of the troposphere. That's the bottom level where most of the air is and all the water is. They go to the very top of the troposphere and it spreads out flat on top, and it gets like what we call an anvil shape. We're like, oh, that's a thundercloud, storm's coming. It's really dark under them because no light can get through. You guys know what I'm talking about?
Yeah.
Okay, that's a cold front. Okay, so warm front, you get like day or two of rain, kind of light rain over the course of a period of time. Shh, YouTube. Oh, cold front is not like that. It's like being at the pool. Yeah, we're having a good time at the pool. There's some clouds coming. We're still going to have a good time at the pool. Oh, thunder. Darn it. We have to get out of the pool. You go hide in the pool. Thunderstorm, 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 thunderstorm. Sky gets clear. 30, 40 minutes later. No more thunder. Get back in the pool and play. Okay, within an hour or two, the thunderstorms come and gone. These things go quick. So which one moves faster, a warm front or a cold front?
Cold front.
Cold front. Now, have you ever thought, what would happen if a cold front going faster than a warm front caught up with a warm front?
Hey.
What would that be? What would that look like?
Pandemonium.
That would look like our fourth front called occluded. Okay? Now, an occluded front, here's the cold front with all this really tall, violent, very heavy rain, short-lived time. Here's our warm front that's really spaced out, light rain over a day or two. Okay? We're in the middle. What's going to happen? All of this warm air that's left here, this warm, wet air, where's it going to go?
Up.
Up. Now you have an occluded front. The cold air is overtaking the warm air, which was overtaking the cool air. Now it rains like a thunderstorm for the length of time that you have a warm front. Okay? So now you have heavy rain over a big area over a long period of time. These things, most of the winter storms that we had were some kind of an occluded front. As they come up, and they're just nasty, big, wet, nasty storms. Okay? And then eventually, the cold air wins, all the warm air is gone, and then the rain just kind of drizzles off, and then you move on. Now, I said originally, Fatima, that these storms start to rotate counterclockwise, right? Okay? So here's your stationary front. Red circle, blue triangle. Red circle, blue triangle on both sides of the line. That's a stationary front. We come over here. Well, as that low pressure starts to rotate, the leading edge, warm front. The trailing edge, cold front. The cold air is overcoming the warm air is overcoming the cold. Well, here's your cold front, here's your warm front. Easy, nice rain, thunderstorm. As it starts to continue to circle, in the very center of the low pressure, you get that occluded front. And that's where you get these big storm systems that move across the country, especially in the winter. These are really bad winter storms. So then the occluded front gets really big. Now an occluded front is a stationary front looks like this. You know, you have like a line with a half circle, and you have a line with a triangle. Right? That's a stationary front. A occluded front uses the same symbols but puts them on the same side of the line. What do you get when you mix red and blue?
Purple.
Purple. Now I don't have a purple marker, but an occluded front is you have your line that would be purple, and you'll have a triangle and a half circle, and a triangle and a half circle. Okay, that's an occluded front, where they've both been mixed together. Okay, and eventually, all the cold air is below, all the warm air is above, it fizzles out and the storm goes away. So this is the life cycle of one of these storms. Do you guys have questions on this? I know I'm going
I'm
fast.
sorry about that.
Okay. So, as we look at this here, we notice that these storm systems come from the west coast. Look, hey, this is that Seattle area where it's really wet and rainy. A little wet and rainy, right? And then it comes and moves itself across the nation. Now, here's a question. Why did this particular storm come down this way? Could it have come across this way? Well, the storm itself is rotating counterclockwise like this. But why didn't this, could the storm go like this?
Is it because the earth is moving?
It's actually, I'm going to tell you that the storm track can change anywhere across the United States. Sometimes they go deep down, sometimes they stay high. This winter we got a lot of these storms, these low pressure systems. What they would do is they would come down and they would come out near Florida. And the low pressure would get here near Florida, and then the jet stream would pull them straight up the coast, and all this warm, wet air from this storm would pick up the Gulf Stream warm water, this warm water current, get really strong, and dump all kinds of snow on the East Coast. That happened to us a bunch of times this winter. Yeah.
Why does it snow more in New York than it does here?
Colder up there. That's the only reason it's colder up there. If you go south of us 20, 30 miles, every snowstorm we get, they're getting rain. If you go north of us 30, 40 miles, every snowstorm we get, they're getting snow. We're kind of right in the middle where we get a little bit of freezing rain, a little bit of sleet, a little bit of snow. And you get snow, rain, and that's why we get less inches. But if you go up toward Pennsylvania and Maryland and even north of Baltimore, they're getting tons of snow when we only get rain. This is why New England is known for all the skiing and things up there, because it's snowing up there all the time. Okay? What controls these are the jet streams. The jet stream is wind that moves at high altitudes, and it pulls these systems along from the west coast to the east coast. And the path of the jet stream determines the path of many of these storms. Right, Montoya? Yeah. I applaud your ability to wake up on an instant, though.
Okay, I get this.
Okay, alright, we're done talking about fronts right now. So the first thing we wanted to talk about was air masses and fronts. Now we're going to talk about severe weather and how to look for it. Okay, what is this? It's thunderstorms. Specifically, it's lightning. I heard somebody say lightning.
I did.
Good. Lightning is nothing more than a static shock
Question.
between the cloud and the ground. You and then you.
Alright, so you see that lightning in the picture?
Mm-hmm.
Where does it hit? Like, does it hit a building, or does it just like hit something that like attracts the
Well,
electricity?
I'm counting here 1, 2, 3, 4, 5. 5 different lightning strikes here from the same probably flash of lightning.
So
now-
flash.
Sometimes lightning hits buildings. Sometimes it hits towers. Sometimes it hits. If everything's flat, it'll hit the flat ground. It doesn't always hit the ground. Sometimes it goes cloud to cloud. Sometimes it's just cloud into space. But usually it goes from cloud to ground. Usually. Yeah,
What
Donna.
happens when I hurt?
Well, Donna, how does it happen?
I was gonna say, if lightning strikes like super duper fast, how do you get a picture of it like that?
That's really hard to do. So usually what a photographer will do is during a lightning storm, they set up their camera where their lens is, the shutter's open. So you can even see that some of these lights down here are kind of blurry. And as soon as the lightning flashes, they shut the shutter so it gets all the exposure of the lightning. That's one way of doing it, but it's really, I've tried to take pictures of lightning, it's hard to do. Because by the time you go to take the picture, it's gone.
Why don't you try it?
Yeah.
Why don't you
Whoa,
try it?
this is not a photography class.
What is the video?
There are videos out there of lightning. Okay. Fatima asked, what does lightning do when it hits the ground? Is that right? So what happens is you have this electrical charge in the cloud. Now, if you guys ever put wool socks on, zap, and you hit your brother or your sister, I shocked you. That's really rude. Don't do that. Why? Because you're electrocuting your friends and your family. Now, a cloud does the same thing. It builds up that electric charge, and that electric charge wants to equalize with the ground. These storms build up an enormous amount of charge, and when they hit the ground, what you're seeing is lightning actually sends electricity to the ground and then back up. And you're seeing a down and back. And what you actually see is the return stroke. So as lightning hits the ground, it's dissipating its charge. And then the ground is equalizing, and it bounces, and then it resets. Now, the lightning itself is over 1 million volts. If you could harness the power of lightning, you could power your home for months off 1 volt of lightning. The surface around lightning is hotter than the surface of the sun. It's seriously hot around lightning. That's why it creates a pressure difference, because it's so hot. Hot stuff tends to be really light in pressure compared to the colder, denser air, and that creates a wave of pressure. And we hear that wave of pressure as
Thunder.
thunder.
Good job, Mom.
Lightning, right? Alright, yeah, say it.
How do you have 675 with this?
I have no idea. You can look it up. Okay, so that's lightning. Now, lightning is associated with thunderstorms. Thunderstorms are these really tall cumulonimbus clouds, and you start with all of this warm air being shoved up over the cold air, and that builds and builds and builds. Rain starts coming down really strong, and eventually, after the warm air is gone, it goes away. And this can happen really quickly. But I want you to understand something. As we go from stage 1, 2, 3 quickly, is it going to run into more moisture right away in a cold front? Yes. Right, because as the cold front moves forward, it's running into more and more wet air. And as it pushes more and more of that wet air out of the way, the storm continues. Example. In the summer of 2001, I was driving home from Colorado on after we were in a camping trip. We'd been up in the mountains of Colorado. Kyle, my stories are way more cool than your stories.
Yes.
We were driving home from a week-long camping trip up in the mountains, and I was in a 15-passenger Ford van. And I was driving, and I've been driving for about 8 hours. And I stopped in Salina, Kansas, and then one of my buddies took over, and then he drove. It was like a 20-hour trip, so we drove in shifts. Well, the whole time I was driving, it was nighttime. I drove into the night, and by the time the sun had set, so I think for about 5 to 6 hours, I was driving due east on Interstate 70 across Kansas, Colorado and Kansas. Here's the thing. I was driving toward a thunderstorm. And because out there in the Great Plains, they call them the Great Plains for a reason. There's not a tree to be seen. Literally, you see nothing but corn and soybeans. Ever.
LOL.
Okay? You're like, oh, look! We were really excited. A grain elevator! Woohoo!
What?
You know those big silos that hold all the grain? Okay? You know, there's a big one in the distance. That was the most exciting thing we saw. It's Kansas, people. It's flat. Okay? So as we're driving through Kansas, I started to see a thunderstorm form in front of us. And that thunderstorm, I probably saw it for 5 or 6 hours. Just in the distance, I saw lightning flash, lightning flash, lightning flash, lightning flash. In the distance for the whole time I was driving. And when I got out of the car in Salina, Kansas, and my buddy took over, we immediately hit the storm. So these things look like they're really short, but they can last a very long time if they continue to encounter this warm air. So that's a thunderstorm. Thunderstorms are dangerous because they can be very windy, and they have lightning, and they have tornadoes. I gotta tell you, I would. Tornadoes freak me out. Not very many things freak me out. Tornadoes are one of them.
Damn, that looks beautiful.
This is actually not technically a tornado, neither is this. What do we call these? We call these
Dang it.
funnel clouds.
Dang it.
These are funnel clouds. The funnel clouds come down, and if it touches the ground, then it's considered a tornado. Now here's how it goes. Yeah. Oh, thunderstorm watch in effect. So you have a thunderstorm watch, and then you're in a thunderstorm warning. And if it's a really, really bad thunderstorm, you'll get a tornado watch. And a tornado watch simply means the conditions are right for a tornado. You're sitting there waiting for a tornado to potentially occur. The storm is really, really bad above your head. And we're using Doppler radar. The weather stations use Doppler radar, and that measures, I'm not going to get into radar here, but the radar measures the storm, and we can tell where it's really, really bad, and we can tell if there's any rotation in the clouds, and so on and so forth. So you can see these things coming with radar. But how much warning do you get? You're sitting in your house. The storm's over my head. We're in a tornado watch. And then someone across town sees these, reports it in, and now it goes from a tornado watch to a tornado warning. If you hear a tornado warning, it means we've actually seen a funnel cloud or a tornado. And that means get your tushy to the bottom of your house so it doesn't get ripped off with you in it. And you need to get to a secure inside wall with no glass. And you don't have a lot of warning. You might have 10-15 minute warning, and that's a lot of warning. And before we had the good Doppler radar, people didn't have any warning other than, oh my gosh, here it comes. So if you didn't see it coming, you were in trouble. What if it came at night when you were asleep? I mean, how often do we have thunderstorms at night? All the time. So
Dang, you're kind of scared.
these things can be very dangerous because you don't have very much warning at all. Okay? Now, so that's a tornado. What is a tornado itself? Well, it is literally the cloud is coming down and touching the ground. Well, it's not really a cloud, but it's wind.
A vortex.
You know how, like, if you drain your bathtub, you get that little spinning thing at the bottom? That's very similar in concept to what a tornado is, except it's wind that's swirling in what we call a mesocyclone all the way to the ground. It's a vortex of spinning wind. And here's the thing with tornadoes. They're very dangerous. But tornadoes are also localized. So here, I'm going to draw in the town of Xenia, Ohio, we had a Walmart. Because, you know, every little town is not a town until it has a Walmart. You know, and how... Okay, then we had a Kroger. A Kroger. Now, you guys might not know what Kroger is. It looks exactly like a Giant. Okay, do you guys know what a Giant grocery store is?
Yeah.
Okay, so you had a grocery store and a Walmart. You know how between these little shopping centers, you have all these little shops, like here's a paintball shop, here's a Chinese restaurant, yeah, or a Subway, or you know, these little shops. And then you have parking, and then right here we had a Hollywood Video. Hollywood Video was like Blockbuster. Before we had red boxes, you actually went to a store to find stuff. Okay, and then we had a tire discounters. And all the rest was parking lot. Okay, shh. This was some of the biggest shopping for the town. It was not a really big town. Tornadoes can be very, very damaging, and they have winds that are whipping potentially up to 200 miles an hour if it's a really bad tornado. And we'll talk about the intensity scale in just a second. Here's what happened. Tornado came into Xenia while I was actually the next town over. The same tornado traveled multiple towns and hit where I was. I'll tell you about that in a second. But before it got there, it got to the Walmart. And it went right next to the Hollywood Video and destroyed the tire discounters. The tire discounters, which is, you know, one of those, you know, you buy tires really cheap, blah, 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 like a Tire Barn or whatever. And The only thing that was left of this brick building was a pile of bricks. And through the pile of bricks, you can see those car lifts that they have, and they were all bent. That was the crumbled remains of a building, literally across the parking lot from the Hollywood video. It saved the Hollywood, because tornadoes are really kind of small, they don't necessarily destroy the whole shopping center. It took out the entire discounters, and then it went and took out most of these shops, and saved the Kroger and the Walmart. The Kroger had a bunch of glass that was broken, and a lot of the cars were bashed into each other as the cars were kind of scootered around the parking lot. But this wasn't a big enough tornado to pick up cars. And it went through here, destroyed this, and there was like a big church right here, and some houses, and it went across the fairgrounds, and then it made its way to the town that I lived in, where I was in college.
What year was
2001. No, when was this? This was 1999. Or 2000. Okay, we had our chapel building here, which was a big, like, conference room. Yeah, and there was a parking lot right here. There was a water tower here. My dorm was right here. And way over here on a hill in the back, there was a truck, fire truck. Now, it was a tornado warning because one had been touched down, so the fire department usually takes all their trucks and spreads them out. That way, if the fire department's hit, they don't lose all of their rescue equipment and they can still help people. Not all your eggs in one basket. So here, this is literally all in one plane, and in the back there's a hill, and kind of in the front is where I had my dorm. 3,000 of us were in a conference, learning stuff. We had a speaker, it was a cool conference, we had a band, blah, 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 blah. This was in the evening. We had a little shed here. On this, back here by this is the water tower, was our track and field in the back, behind this, maybe 100 yards behind us. The tornado, from what the guys here told me, came, because I talked to the firemen who were here, and it caused their truck to start spinning 360s as the tornado went by them. Their truck is spinning. The tornado went by them, it levels this shack and throws insulation and equipment everywhere, and then the tornado path goes right up over the building, with 3,000 of us in the building. So, I'm not a big fan of tornadoes. But this is, you know, the kind of things they do. They'll hit something, they'll skip something else. They missed the water tower, but hit the shack that was right next to the water tower. You know, and then they jumped over our building. You know, why didn't they pick up his truck? I don't know. It's just the way that one occurred. So tornadoes can be really random in the damage they cause. Let's talk about the scale of these tornadoes.
how did they form?
A tornado forms because I'm going to say the book has a really good description of this, so if you don't like the way I say this, read the book section on it. But here you have your cloud. The wind speed at different levels of the cloud is different. So the wind speed here is one speed. The wind speed here is another speed, and the wind speed up here is another speed. Because as you go higher in the sky, the wind speeds change. And what happens is, this is causing like an offset spin, so you start getting this rotation in a cloud, and this rotation can start to come all the way to the ground as it's being spun like a top. That's the simplest way that I can describe it. Does that answer your question a little bit? Okay. And that's why these happen in these big thunderclouds, because they're so tall and there's all this rotation going on in the cloud. Okay. We categorize them by F0, 1, 2, 3, 4, and 5. It's the Fujita tornado intensity scale. You don't have to remember that. Just know that we categorize them as F1 through 5. An F0, oh come on, that's less than 70 mile an hour winds. A house can withstand 70 mile an hour winds. That's not really damaging at all.
Sorry.
No big deal. F1s, 2s, and 3s are kind of common, especially F1 and F2. This is where you're starting to get some damage. Maybe the peel surface off roof. So like you lose some, asphalt shingles off your house and no big deal, or maybe some hail damage. You get to an F2, now the wind is booking. This is 181 to 253 kilometers per hour. Fast! Like over 100 mile an hour winds. Okay? Light object missiles generated. The most damaging thing about tornadoes is not the spinning wind itself, it's the fact that the spinning wind picked up Dominique and turned her into a missile and threw her at something. And then she smashed into something. Okay, so maybe not Dominique, but maybe it ripped the earrings out of her ears and that earring hit somebody and that actually was going so fast it hurt. It has been documented that 2x4s can go through brick walls because they're being thrown so fast by the wind of the tornado. They've seen pieces of grass get stuck in trees because they hit the tree so hard.
OD.
So, it is weird. Mythbusters did a bunch of testing on it, but it's documented. It happens all the time. The most devastating damage are the F5s. Now, have you guys seen the movie Twister? It's a really old movie nowadays, but Twister does a really good job describing tornadoes. It's a sensationalized movie, of course. We might watch it after SOLs are done and we've done some other stuff. But an F5, the thing about an F5, like the tornado that I described to you, missed the Hollywood video but hit the tire discounters and missed the 2 grocery stores. This same town in the 1970s got hit by an F5. It leveled the entire town, practically. Because an F5, the tornado, the base of the tornado is not necessarily the size of a store, but the size of like a quarter mile to a whole mile wide. When they're that big, just run. No, don't run. Get to cover really as fast as you can, because you can't outrun the tornado. And then tornado might be going this direction and go and take a right. And if you're right there, that's bad.
If you get caught in a tornado, like, do you sometimes land gently or is it always fun?
If you get caught in a tornado, you're going to be spinning at hundreds of miles an hour
I don't know,
and
I just
thrown
finds down.
at elevation. Are you going to land softly?
You gonna die. You gonna die.
No, it's not going to be fun.
You gonna
Okay.
die.
F5s are not, I don't want you guys to think that, oh my gosh, we're going to have an F5 with every thunderstorm. So, great thought. They do not happen very often. We might get one a year in the United States. Maybe 1 or 2, if that. They're not super common because it takes a super big storm to develop those, but I think they've caused a lot of damage. Tornado Alley runs from Texas through Oklahoma, through Kansas, up into the Midwest. So, but we do get tornadoes here. When I moved to Virginia in 1995, we had a tornado. A couple years later, we had another tornado. We've had tornadoes since then. We haven't had that many down here in Woodbridge, but we've been having them 30 miles north of us. So don't think that you're immune to tornadoes because we're here. That's why we have tornado drills where we go downstairs and sit against interior walls. Okay? Now, tornadoes. That's tornadoes. Let's talk about hurricanes because I want to get moving here. Hurricanes, the last thing I'm going to talk about, and then we're going to be done. I know, exciting. Hurricanes are whirling tropical cyclones with wind speeds greater than 74 miles an hour. Oh yeah. Okay, now while a tornado is a localized small wind vortex, a hurricane is a giant freaking storm that smashes into things. It starts off as a low pressure system and it's a rotating storm. It's got super high winds. They start in really warm water because all that warm water is evaporating. Remember how I said all that energy in the evaporation gets caught into the clouds? Well, all this energy is going into the storm, and these things they rotate, they spin in the northern hemisphere counterclockwise. So the storms are going like this. They usually localize around the central point, the low pressure system. That's what we call the eye of a hurricane. And they're rather damaging. But the difference between a hurricane and a tornado is, tornado, you're like, okay, it's a tornado watch, tornado warning, go to the basement. You know, you have 15, 20 minutes if you're really, really, really lucky. Hurricane. Okay, there's a storm developed off the Bahamas. Okay, 4 days later, storm's on its way to Northern Virginia. Okay, a day or two later, storm hits Northern Virginia. You've got quite a bit of time before the tornado gets to you because we have satellites and other really cool things that we can measure these hurricanes with and track them. We even send a C-130 Hercules aircraft, specially designed to withstand these things, into the hurricane itself to collect data. Tornado would rip the plane out of the sky. Besides the fact, tornadoes are here and gone. Like a tornado could come on the ground, and then gone. The longest tornadoes could last up to 300 miles on the ground, but by the time you realize it and then prep the crew and get the crew into the plane, it's going to be gone. But these things last for a week, could last for a week or 2 weeks. As they start down, way down in the warm tropical waters, as a big storm system, and that starts to rotate, and it starts to rotate faster, and before you know it, it's chugging toward the United States. Or Mexico, for that matter, or all the Caribbean islands often get smashed with these hurricanes.
Are they more dangerous than tornadoes?
Are they more dangerous than tornadoes? That's a hard call.
I'm liking that.
Okay, the thing with a hurricane is that a tornado is smaller than this little bit right here. So if a tornado hits you, you are in a load of trouble. If a hurricane hits you, the whole city's in a load of trouble. A tornado is localized, super fast winds. A hurricane is, the entire thing has winds in excess of 70 miles an hour, up to 150 for a really, really bad one. So then you have what you call straight line winds, where the wind is constantly pounding. Or if you look outside, oh look, our tree's laying down on its side. If you ever looked outside and see literally trees bent all the way to the ground, that can destroy trees, bring down power lines. They're specially designed, and I don't know, I think they're crazy. But they do it anyway.
How'd you do that?
No way. Not a chance. These things absorb quite a bit of water, and here you can see this counterclockwise rotation. And then the eye, let's talk about the eye. The center of the storm is called the eye, and usually, if it's really, really powerful hurricane, it develops an eye, and they're always talking about in the news, the eye of the hurricane is forming very well right now. If you ever watch like the Weather Channel, they get really excited about hurricanes. It's bad. It's beautiful. Right? It's kind of this weird dichotomy where they love the storms, they want them to happen, but they don't want them to hit anything. Now, the eye of a hurricane, I don't know if you saw here, just really quick, the air is descending in the eye. What do we know about air that's sinking?
Colder.
Not necessarily colder, but are you going to have clouds with sinking air?
No.
No, so truly, you'll have this giant storm system that could be 600-700 miles wide, and the very middle of it, there's no clouds. The eye of the hurricane. So, if you look outside on the bulletin board, I have a picture of Katrina when it was beautifully formed, and there's this beautiful round eye of the hurricane. And what happens is the hurricane's coming through, and if you're in the path of the eye, oh, thank goodness the hurricane's over, the sun is shining, the wind is gone. Yes! Oh crap. Because you just got hit by the first part of the storm, and now the second half of the storm is coming, and it's even worse than the first half. Get back inside. Shut the door, lock it, go inside. So the winds of the hurricane can be very, very damaging, but what's really bad with the hurricane is more than just the wind. It's the storm surge. Do you guys know what the worst hurricane or the most damaging hurricane ever to hit the United States is?
Katrina?
Katrina. And do you know what city was hit by?
New Orleans?
Not New Orleans.
Holly Grove.
It was Biloxi, Mississippi.
Yeah, I knew that.
Okay?
Thought he was.
Yeah.
Everyone, unfortunately, remembers Hurricane Katrina because most of the damage of Katrina was not, Biloxi was wiped off the map, but Biloxi is a smaller town compared to a giant port city like New Orleans. Unfortunately, the problem with New Orleans is, here's the Mississippi River, okay? Here's a levee to hold the Mississippi out of, so this is the Mississippi River. Here's New Orleans. Okay, New Orleans is here. Let me build some buildings here. Maybe the Superdome in the background. Okay, some more buildings. Okay, now there's another levee over here. Now when I say levee, that is an artificial hill or wall built to keep the water out of the city. So they have levees on the Mississippi to keep the river from flowing into New Orleans. Because do you see how the Mississippi is level? Like if I put a boat here, here's my boat. If the boat is here, you're actually higher than the Superdome in elevation on the Mississippi next to New Orleans. Okay, and here's the ocean. Okay, are you starting to see the problem with New Orleans?
Yeah.
New Orleans is sinking. The reason New Orleans is sinking is they built New Orleans on river delta sediments, which tend to be very loose. And over time, they just get compacted and they sink. So the entire city is losing elevation. The Mississippi River is gaining in elevation because all the sediment coming from the mountains and the plains is filling up. So the Mississippi River is actually getting higher, New Orleans is getting lower, and that means the city is
Doomed.
doomed.
How long does the city have?
It's already been destroyed once. It's
Yeah,
not,
but please,
it's not recovered, it still hasn't recovered. Since, in 10 years, it still hasn't recovered. It's doomed. If it gets hit by another storm, it's gone. And then they'll try to rebuild it again, and then it'll get hit by another storm, it's gonna try to be rebuilt again. And until the Mississippi River changes course, they're gonna keep trying to rebuild New Orleans. Problem,
So
New
what you're saying,
Orleans
history
is
is gonna
still
keep
sinking.
Just be quiet.
Agreed. I agree. You guys seem to see the logic of that, but I mean, what if it's your house? You don't want to leave your house. You know, you've lived there your whole life. You don't want to just. How can you just move? It's really hard on both sides. It's one side says, well, that's dumb. The other side says, but how could I ever leave? And all the culture that is New Orleans, people don't want to leave it, and I understand that. I respect that. I think you're nuts, but I respect it. So here's the problem. This is New Orleans as we know it today, and there's a lot of factories and things, so I'm going to call this a factory. Factory. What did New Orleans have? It's a major port city. It has a lot of industry. So a lot of oil refineries and petroleum and gasoline and chemical companies are based in this bowl-shaped city of New Orleans. Now, Hurricane Katrina shows up. If Hurricane Katrina had actually hit the city dead on, like they were afraid it was going to, there would not be a New Orleans today. I promise you that. It would not have existed. Because it would have changed the course of the Mississippi River. We can talk about that at a different time. But what did happen is the storm surge hit New Orleans, because on the northwest side of storms, the storm surge is the worst. What's a storm surge? Have you guys ever been in a boat, and you kind of like in front of the boat, the water gets a little bit higher in front of the boat? It's called like the bow wave in front of the boat. Or if you ever watch Michael Phelps swim, he creates a bow wave in front of him because he's going so fast in the water. And the water's actually higher in front of him than it is behind him. Storms do that too. And these big hurricanes push all of this water, because you have 150-mile-an-hour winds pushing the water out of the way. So the water is getting pushed in one direction and starting to pile up in front of the storm. Well, I think 30 feet is a little excessive. We'll go with like 20 to 25 feet. Well, I think the storm surge for Katrina was about 22 feet. Now think about that. What does that mean? That means the ocean has risen in sea level over 20 feet. Problem, the levee did not have 20 feet. I think it had 15 feet. Do you see the problem here?
Yeah.
So not only is the ocean now way up here, the levees broke, and all of this water started pouring into the city. Question, Ingrid?
What's it called? What amount of time did it like rise?
What amount of time? The water starts to rise.
One.
When?
Like,
When did it start?
yeah.
When did it start?
The storm started heading toward Katrina. Now I'm just going off pure memory here. The storm started heading toward Katrina. The people were warned it was coming, but they were hoping it wouldn't hit their city. So a lot of people said, I'm not going to leave. We've had hurricanes before. We'll be fine. And then some people chose not to retreat. Some people wanted to evacuate, but couldn't afford to. The government in Louisiana was not known for its uprightness and integrity. They were known for being corrupt. And that's unfortunate because they weren't maintaining the levees, so a lot of the levees failed and they broke. And then the government had a whole lot of buses and other things that they could have loaded everyone up and got them out of the city, and they didn't. It was a mind-numbing tragedy what happened. It shouldn't have happened, it happened. The city was going to be destroyed no matter what you're going to do, but the loss with the people didn't have to be as bad as it was. So there's a lot of problems. But over the course when the storm came in and hit, if the storm is one day away, you can still get in your car and drive away and be safe. Because you can drive, the storms move at like 10 to 15 miles an hour. You can walk fast enough to get far enough away if you have a day to get away. But as the ocean rose, I think over the course of 6 to 12 hours, but the ocean's rising, the winds are pounding the city. And not only that, it's raining really hard, so they're getting full of rain. But most of their damage came when the levees broke and the ocean just rose up over the levees and just spilled into the city. And then the pumps, they have pumps to keep the water out of the city, all the pumps failed. So they couldn't even keep the water out. So now, the factories and all the houses and everything's filled with water. What are these factories full of? Chemicals. So now all the water is not only full of ocean water, but it's chemical sludge, ocean water and sewage. It was bad. Most of the houses had to be completely destroyed or abandoned and then destroyed later. Yeah, say.
Do you think New Orleans will become like Venice,
Like Venice?
yeah,
It's a different problem. I understand sinking, yes, Venice is sinking, but it's sinking for a completely different reason. Venice is on a lagoon that's been cut open, so that's why Venice is sinking. Venice is not below sea level. New Orleans is below sea level. It's a different problem. But you're thinking the right way. So this is some of the ways that hurricanes can be really damaging. Now, we knew it was coming. We had satellites that told us it was coming. It's coming, it's coming, it's coming. Ah! Hurricane!
One more?
Run away!
One more?
Okay?
Thank you.
You're gonna do a lab today. I'm gonna give it to you in just about 3 minutes. And that's gonna be your quiz for the rest of the class is going to be this little hurricane lab. You're gonna go through and plot out and using a map the points of the path of a hurricane. And that will show you hurricane speed and all about this is my last slide. This is the scale for which we rate hurricanes. So upwards of 250 kilometers an hour or 150 miles an hour, something like that. Sustained wind speed. You're going to see all of that in your lab. You're also going to practice your mapping. So let me hand that out. That's the end of the notes today. This is severe weather. Do you guys feel like